Hello class. Today I'm going to try to explain to you exponential and logarithmic functions and equations. Today we're going to basically stick to functions. We'll look at equations in the next day or so. So the agenda for the day, we're going to look at logarithms and exponentials as inverses. I need you to understand that those are inverse operations or inverse functions. Next we're going to find the value of a log using exponentials. And then we're going to contract and expand logs, and then we're going to look at the change of base formula. So let's get started. First, logarithms and exponentials as inverses. So first you have this statement, log base b, so watch my cursor as I read this, log base b of x equals y, if and only if b to the y equals x. So let me say that again. Log base b of x equals y if and only if b to the y equals x. So what this is trying to say is that for every log there is an inverse exponential. So let's do a little bit of practice on this so we can kind of get an idea of what this means in example, because looking at a statement like this is oftentimes confusing. So sometimes students understand better when they see it in example. So we're going to basically, I'm going to copy this because I want to remember this, so I'm going to use it later. So what is the logarithmic form of each equation? So what I'm going to do is I'm going to right click my mouse and I'm going to paste what I copied earlier. So I need to keep this in mind as I'm thinking through this. What is the logarithmic form of each equation? Well, this form right here is logarithmic. This form over here is exponential. So I need to basically decipher this exponential. It's b to the y equals x. So this is b to the y equals x. So where I got this from was over here with this exponential. Now I'm basically going to take the time to record what everything is. X is 100, B is 10, and Y is 2. So now I'm going to put it into this form. I'm going to say log base B, so that's 10, of X, so that's 100, equals 2. So for this exponential here, this is the inverse log. Okay. Now, right now, we're just practicing writing them back and forth, basically. In the future, when we start to look at logarithmic and exponential equations, you're actually going to use them to solve for things, to solve for variables. But right now, we're just making sure we understand how to go back and forth. So this would be my answer. That's the logarithmic form of that equation. So let's look at another example. I've got 81 equals 3 to the 4th. Now, I remember from the last slide, because I just did this, that x equals b to the y. So I'm going to write down what everything is. X is 81, b is 3, and y is 4. Now I need to rewrite this as a log. So it's going to be log base b, which is 3, of x equals 4. Okay, so I'm literally just doing that from memory because I'm thinking back to this slide and I'm remembering this form and I'm remembering this form. Now, of course, that's going to be easier for me right now because I'm a teacher. I've been doing this for a few years, and so I've kind of have this memorized already. But the point that you should get to is where you have these two forms memorized and you can go back and forth between them. It's actually easier to go from a log to an exponential, and I'll show you a trick later when we get to that. Well, let's look at another example. Now, of course, remember the things I recommend when you're watching a screencast. When you start to feel like you're catching on, I recommend you pause the video, work the example, try to stay ahead, and then you can watch me work it to check yourself. You should always, always, always be working on making yourself independent with the material. Don't just watch me do everything and then think that you know how to do it. Make sure that you get to the point where you're doing everything before I do, and then you're just using this video to check yourself. So I'm remembering x equals b to the y. I'm also going to remember it's log base b of x equals y. So over here, x is 36, b is 6, and y is 2. So when I put that over here, I've got log base 6 of 36 equals y, and there's my answer. Okay? I'm literally just figuring out which one of these numbers is what letter and then putting them in this form over here. I'm not doing anything more complicated than that. Let's look at another example. Even though this is fractions, doesn't change a thing. It's x equals b to the y. So x is 8 over 27. B is 2 over 3. And y is 3. Okay, so remembering my other form, I've got log base b of x equals y. Log base b, so 2 over 3, of x, so 8 over 27, equals y, which is 3. It doesn't matter that they're fractions. I still treat them as x, b, or y. Okay, let's continue. Now we're going to switch gears. I just showed you that logarithms and exponentials are inverses, and basically showed you how to go from an exponential to a logarithm. I've shown you how to go from exponential to log, and later in the lesson I'll show you how to go backwards. But now we're going to focus on finding the value of a log using exponentials. Okay. So what is the value of log base 8 of 32? So log base 8 of 32, we know this should equal y. So now I'm going to show you how to go back. So this is the trick I mentioned several slides ago, that I think it's easier to go from a log to an exponential. We're going to use the exponential to solve this. So I'm going to start with my base. I'm going to trace around like this. Miss Buchanan calls it the loop. And this is where I start. So I have 8 to the y equals 32. So that's 8 to the y equals 32. So that's how I can go from a log to an exponential. And most students agree that that's the simpler thing to do. Now, this is where it gets a little bit more complicated. Here, I have to take these numbers and break them down into something with the same base. So what I notice first is that they're both even. So I'm going to take 8, and I'm going to see if I can make it into a bunch of 2's. So that's 2 times 4, and that's 2 times 2. So 8 is nothing more than 2 cubed. 32, that's 2 times 16, which is 2 times 8. And I now know that 8 is 2 cubed. So this is 2 cubed to the 4 to the 5th. So 32 equals 2 to the 5th. So now I'm going to rewrite my bases as these 2 to an exponent. So this is really 2 to the 3rd power to the y. I replaced 8 with 2 cubed. And 32 is really 2 to the 5th. So I'm going to put 2 to the 5th here. Now I'm going to multiply these two exponents so I can get rid of these parentheses. This is 2 to the 3y equals 2 to the 5th. Now that I have the same base, what I'm going to do is I'm going to apply a piece of logic that since the bases are the same, if these two sides of my equal sign are going to turn out equal, then really just my exponents have to be the same. A lot of people will actually tell you that the 2's cancel out. Like once you have them into the same base, you can kind of do this. The 2's cancel each other out, and now you have 3y equals 5. So I would divide both sides by 3, and y equals 5/3. So up here with the question, what is the value of log base 832? I would put 5/3. Okay, that's the value. Now, I recommend you probably watch this example 2 or 3 times before you move forward. Make note of each of the steps. Notice how I broke the numbers down. I may not use this exact same strategy every time, but before you move forward, you should make sure you understand this example. Okay, so I'm going to look at the next example. Log base 5 of 125 equals what? I'm going to say 5 to the y equals 125. So 5 to the y equals 125. I am going to use the same strategy as last time. I'm going to try to break these down. I know 5 is prime, so I can't. So I'm going to break down 125 and see what happens. It ends in a 5, so 5 goes into it. So that's 5 times 25. And this is 5 times 5. So 125 is nothing more than 5 to the 3rd power. So 5 to the y equals 5 to the 3rd power. So for these two bases to be the same, if I still want to imagine that they cancel out, my exponents must be equal. So that means that y must be 3. And you see I have nothing to solve, so I'm actually looking at my answer. So y must be 3. Okay? So I use the exact same strategy there. Next one, something very similar. Log base 432 equals what? So I'm going to say 4 to the y equals 32. So 4 to the y equals 32. I'm going to try to break these down into the same base. So basically I'm going to do my prime factor trees. 4 is pretty simple. It's 2 times 2, or 2 squared. 32, we just broke that down. So I'm not going to do that again. 32 broke down into 2 to the 5th. Okay, so I'm going to replace 4 and 32 with these expressions. So I've got 2 squared to the y, and then I've got 2 to the 5th. I'm going to multiply these two exponents. So that's 2 to the 2y equals 2 to the 5th. Now that I have them in the same base, I can basically just cancel out the bases, and I get 2y equals 5. So I divide both sides by 2, and y is 5/2. Okay? So that's basically how you can use an exponential. Notice this is an exponential here that I'm circling. This is an exponential. You can use an exponential to solve a log because they are inverses. They're inverses the same way that, what would we say, addition and subtraction are inverses. Squaring something and taking the square root of something are inverses. Multiply and divide are inverses. They basically, quote unquote, cancel each other out. So we can use an exponential to solve a log. Now, let's change gears and look at contracting and expanding logs. This is going to be a little bit simpler. Excuse me, this is going to be a little bit simpler. So I hope that you will find this to be a little bit more relaxing. You'll notice we have 3 properties here. We have the product property. So if you have a log with a base where 2 things are being multiplied inside, you can split that up into 2 separate logs, taking one of the inside pieces to one and the other inside piece to the other. Similar thing with division, the quotient property. If you're dividing these 2 things, you can separate them with subtraction. And if you have a power property, you can bring the power out front of the log. This third property is actually incredibly useful when solving logs. So this is something I'm going to want you to focus on, is the power property. So let's dive into an example. It says, what is each expression written as a single logarithm? So the first thing I do is I note that my bases are the same. That's a good thing. That means I can combine them. And then I notice here that I have subtraction. Now if I go back to my properties, subtraction has to do with the quotient property. So I'm going to do something to this effect here. Okay, so I'm going to combine these as log base 4 of 32 divided by 2, and that simplifies. So this is log. That's not log. Let me erase that. That looks horrible. So this is log base 4 of 16. Okay? So you should simplify if you can. So this is the simplified form. But most importantly, you understand to do this operation with these two numbers. That's what you're kind of learning. Hopefully you know that 32 divided by 2 is 16. Hopefully I didn't teach you that. Let's look at another example. I notice I have a couple properties here. First, I check to make sure that my bases are the same, and they are. I see that I have division. So instead of dividing the x and the y, I'm going to multiply them. I also see that I have a number out front. So I'm going to have to use the power property. So this is going to involve the product property and the power property. The first thing I'm going to do is I'm going to bring the 6 inside. So I'm going to have log base 2 of x to the 6th power plus, oh, I didn't notice this, now I do. I'm going to bring this 5 to the y, log base 2 of y to the 5th. So I bring my coefficients inside to make exponents. Now I'm going to put them together with multiplication. So I have log base 2 of x to the 6th, y to the 5th. Most students seem to understand these properties better when it's done with variables because they can see everything has stuck around. But there you go. So that's log base 2 of x to the 6th, y to the 5th. Let's look at another example. Notice my bases are the same. So I'm going to combine these two things with multiplication because this is an addition sign. So this is going to be log base 4 of 5x times 3x. I can simplify this piece. So that's log base 4 of 15x squared. And there's my answer. Okay. Here, I notice my bases are the same. This tells me I'm going to have to do some division, and I'm going to have to bring this exponent inside first. So I'm going to write an intermediate step, log base 4 of 6 squared minus log base 4 of 9. So I'm going to write this as one log base 4 of 6 squared over 9. I can simplify that. Log base 4, 6 squared is 36. And I can simplify further. This is log base 4 of 4. And while we have this opportunity, even though this isn't the focus, when you ever have log with a base and the same number here, so log base 4 of 4, log base 5 of 5, log base x of x, if the base and this number both match, it's 1. Okay? So the answer to this is 1. All right? So you only put 1 if the base and this number match. Now, let's do this backwards. What if we expanded these logarithms? Well, I notice that I have division. Division goes along with subtraction. So I'm going to say log. Now, notice I don't have a base written. The assumed base, when it's not written, is log base 10. So we assume there's a 10 here, but we don't write it. So I'm going to say log base 10 of 4x minus log base 10 of y. Okay, I've taken care of everything. I cannot pull this 4 out front because it's not an exponent, it's a coefficient. So you have to keep that in mind. Next example, log base 9 of x to the 4th over 729. So I'm going to split this up into log base 9 of x to the 4th minus log base 9 of 729. This will come out front. So 4 log base 9 minus log base 9. Oh, I forgot my x. Apologize. Log base 9. It's a horrible looking 9. Let me fix that. I'm just going to start over. I can always go in and edit this out in Camtasia. So log base 9 of x with a 4 out front minus log base 9 of 729. And there's my answer. Next example. This is going to be log base 3 of 250 minus log base 3 of 37. And there's my answer. And log base 3 of 9 plus, because this is multiplication, log base 3 of x to the 5th. Then I'm going to pull this exponent out front. Log base 3 of 9 plus 5 log base 3 of x. And there's my answer. So that is how you both contract and expand logs. Hopefully you saw the same rules over and over again, just front and back. And that's really what you need to understand there. Last thing we're going to talk about is the change of base formula. This helps when solving logs. And I'll go back to a previous example where I could have done change of base and show you what we could do. But first, this is the change of base formula. What this means is if you have log base b of m, this could be any base and this could be any number. You could split that up into logs of the same base and then put m on top and b on bottom. Now this is difficult to understand, so let's look at this in an example. What's the value of each expression? This may be a little bit difficult to solve. Now my chosen base here, when I choose the c value, I always do log base b, or log of 10. The reason I do log of 10 is I can go to my calculator, which you'll see in a second. So I'm going to say this is log base 10, notice I don't write it, of 27 over log of 81. Now before I go to my calculator to tell you what this is, I want you to notice a lot of students will get these numbers mixed up. They'll put the 81 on top and they'll put the 27 on bottom. The way I remember it is the 27's bigger, so it goes on top. I know it's not a perfect way to remember it, but it's the way I remember it. So the bigger number goes on top. Now I'm literally going to pull up my calculator. Unfortunately, my calculator is not working right now. So I'll have to show you this in class or in person. But here I would go to the calc, and then it would tell me an answer that I would round to 3 decimal places. And I'll show you this in class. So if you want, you can always just Google search how to do a log in your calculator and it'll tell you. So next, I'm going to do this example. I'm going to change it to base 10 so I can use my calculator. So log base 36 over log base 5. And then I would put that in my calc. And I would round to 3 decimal places. Okay, it's that simple. Log base 8 of 32. So log of 32 divided by log of 8. And then I'm going to put that in my calculator and give 3 decimal places. So log of 18 over log of 4. And I'm going to put that in my calculator and give 3 decimal places. And so that really concludes the lesson. I told you I was going to go back to one of the previous examples, which I'm going to do now. Here's a place that we could have done change of base. So let me erase this. Here we broke it down. We turned it into an exponential, and then we broke it down. But I also could have done log of 32 over log of 8. I would have put that into my calculator. And I bet you I would have gotten something that's similar to 5 divided by 3. So if you put this in your calculator, and then if you do 5 divided by 3 right after it, you better get the same thing. So really you can see, hopefully now, that you kind of have a choice in what you do, and it's really up to you to pick which may be the best. So hopefully over the course of the next about 7 days, we'll be able to see enough examples that you'll be able to decipher what's the best and when. So to review, I showed you that logarithms and exponentials are inverses, and I've shown you how to go back and forth. I've shown you how to go from logarithms to exponentials, and I've also shown you how to go from exponentials to logarithms. Showed you how to find the value of a log using exponentials. Showed you how to contract and expand logs. And we just finished up with the change of base formula, which I hope was very, very simple. So that concludes this screencast. Hopefully you'll be able to be successful with this now. And best of luck to you.